Hey guys, welcome to your very first flipped classroom lesson. Today we're going to be talking a little bit more about that word matter that we talked about in class today. So let's go ahead and jump right in. So first of all, I have four images on your screen. I have a gold bar, an apple, a baby, and some iPhones. Sorry to everybody that's an Android fan, but I'm definitely an Apple fan, okay? So what do these four things have in common with one another? All four of these things are considered matter. So how do we define what is matter? Well, matter is going to be anything that has a mass, anything which has a mass. So an apple has a mass, a baby has a mass, an iPhone has a mass, okay? And not only does it have a mass, but it also takes up space, okay? So it takes up some space. So you might be thinking to yourself, well, what are some things then that are not matter, right? Because a lot of things out there in this universe take up space and have a mass. So some things that are considered maybe not matter, and maybe you're able to think of these on your own. If you want a challenge, pause the video right now and think about it. Otherwise, some things that we don't consider matter, a good one to think of is fire, right? Fire is beautiful, but it does not have a mass and it doesn't actually take up any space. And another one that I love to use as an example is a rainbow or light, right? As beautiful and as big as a rainbow can be in the sky, that light, that colored light, actually doesn't take up any space at all, okay? So that's what matter is. Now let's go ahead and move on and talk a little bit about how we further categorize matter. How do we subdivide matter into different components then? Because a gold bar, an apple, a baby, and an iPhone are all very different from one another. So let's start with that gold bar, for example. So a gold bar is made up of purely one type of atom, and that's the gold atom, okay? And therefore, gold is considered an element, okay? And so by definition, an element is a substance. And notice we're using that word substance. Everything is considered a substance that is composed of only one type of atom. Okay, so every single atom that is in that gold is the same. Okay, so they're identical, and therefore they are made of only one type of atom, and therefore it's an element. All right, so let's go ahead then and talk a little bit about what is a compound. Okay, so a compound is slightly more complex. Okay, but a compound also, like the element, is going to be considered a substance. Okay, and so a compound is a substance, okay, that is composed of two or more types of atoms. Okay, and not only is it composed of two or more types of atoms, but there's some more key information that we need, and that is that they are chemically combined in a fixed ratio. Okay, so they are chemically combined in a fixed ratio. So that term fixed ratio sounds kind of scary, but it actually just means that every time we have that same compound, that they're always combined in the same ratio of atoms. So what do we mean by that? Let's give an example. So one compound that we're all familiar with is H2O, or water. So anytime you have a water molecule, you turn on your faucet at school, you turn on the faucet at home, we're getting the water, and it has two hydrogens for every one oxygen. Okay, and so it's also possible to have compounds made of something that is not 2-to-1 ratio. For example, hydrogen peroxide, which is going to be a 2-to-2 ratio, 2 hydrogen for every 2 oxygen. Okay? All right, that leaves us with one more type of substance to talk about, and that's going to be a mixture. Now, a mixture is actually very similar to a compound. There's just a few small words in the definition that are very, very important. Okay, and so a mixture is going to be a combination of two or more substances okay? And those substances can be elements or compounds, okay? And they are not chemically combined, okay? So they are not chemically combined. What does that mean? That means that I can take two things to mix them together. Like let's say I took water and iron and mixed them together. Okay, that means that I can very easily separate those two things. They don't undergo any sort of chemical reaction when I put them together. Okay, and how can I separate them? There's going to be an entire lesson that we're going to talk about on separation of mixtures. But something that I do want to make clear here is that in mixtures, all of the components retain their properties, right? So how then do we think that we can get iron out of water? Well, what's a property of iron that's really unique, right? And it's the idea that iron is actually magnetic. So I can take that iron out because just because I put it in water doesn't make it non-magnetic. Okay, does that make sense? Awesome. So let's go ahead and continue on. Okay, and let's talk a little bit about a pure substance. Now, you'll notice that we use the terminology substance a lot in this lesson, but there is a difference between a substance and a pure substance. Now, I want to point out right from the very beginning that pure substances have to be composed of the same type of atom or molecule throughout. Okay, so they have to be composed of the same type of atom or molecule throughout. So any idea of which of our three are going to be considered a pure substance? Okay, so elements are considered pure substances as well as compounds. But if you think about our definition of a mixture is not a pure substance, right? Because it's composed of different types of atoms or molecules throughout. Now, if you think back to our lesson from class today, we spent some time talking about how we're going to visualize or represent things on paper, right? We learn about chemistry through observations, explanations, and then representations. So we've talked about our observation of the different things, right? The gold bar, the baby, the apple, and we go ahead and we explained it, right? We talked about defining them as whether they're elements or compounds, and now we're going to talk a little bit about how do we represent or visualize that, and we do that through what's called a particle diagram, okay? A particle diagram, and those are going to be our visual representations, okay, of the elements, the compounds, or the mixtures. Okay, so the particle diagrams are the visual representations of matter, okay, on the subatomic level. Now, if you're following along on a notes sheet that I provided for you today, there are 3 particle diagrams. I'm going to do my best to just quickly kind of sketch those. I'm only going to really do 2 or 3 of each molecule. That way we can kind of get through this quickly. But I will say, okay, let's take a look at our first one. Our first one is a combination of this molecule and this molecule, okay? So these two are, I drew the same thing, sorry. So here we go. So then of this molecule as well, okay? So you notice that we have molecule A, and molecule B, and they're all placed together in the same container. Now you have to look at it and you have to say, are these chemically combined or are they not? Are they same or are they not? So we have 2 different types of molecules not chemically combined. Therefore, this would be a mixture, okay? So again, these are not chemically combined, and there are 2 different molecules, again, not chemically combined, right? They are not sticking together. Okay, our second particle diagram that we have there, okay, is a series of this, okay? And you'll notice that they're singular And so those are going to be atoms. So what is this if we have only one type of atom present? This is an element. Okay, again, only one type of atom present. And that leads us to our last particle diagram, which by process of elimination, we can probably guess what it is. But let's go ahead and talk about it. We have a bunch of this. So we have at least two, but we definitely have way more than that of this molecule right here. Okay, it is the same throughout. You'll notice that they are all stuck together, so that represents a chemical combination and that they are identical. So this is going to be a compound, and these are the same the same molecules throughout. So this actually helps us visualize this definition of pure substance, right? Because we have, remember we said it's composed of the same type of compound or atom or molecule throughout. So elements are pure and compounds are pure. All right. So let's go ahead and very quickly then add our definitions of atom and molecule since we've been using those. So an atom is going to be the simplest form of matter. And it's singular. And we typically represent it with this nice little ball like this. And we have our molecules, okay, our molecules, which are going to be a singular unit consisting of two or more atoms chemically combined. So atoms are typically used to talk about elements, right? So we can say they're typically used to talk about elements. So I have gold atoms, not gold molecules, okay? And then I have molecules, which are typically used to talk about compounds, right? So you don't say I have water atoms, you would say I have water molecules. But there are some exceptions to this molecule rule, okay? And I want to point this out quickly. So for example, oxygen, right? The oxygen, the good stuff that we breathe, has the chemical formula O2, which means that it is consisting of two identical types of atoms that are chemically combined. Well, is oxygen an element or is it a compound? Okay? And it's actually what we call a diatomic element. Okay? And it's a diatomic element, again, because it has two of the same type of atom chemically combined. And so since it's only the same type of atom throughout, it is considered a diatomic element. There are 7 diatomic elements that exist in nature, and we do need to know those. Okay? Again, they only exist in nature, and we'll continue talking about that this year. But hydrogen is diatomic, oxygen is diatomic, fluorine is diatomic, bromine is diatomic, iodine, nitrogen, and chlorine. So these only exist in nature in pairs. Okay? That's our first lesson, guys. Thank you so much for tuning in. I'm looking forward to working with you guys tomorrow. Have an awesome rest of your day.